Okay, we're going to look at finding the equation of a tangent to a curve. Here's the question: find the equation of the tangent to the curve given by this equation, y is equal to 4x squared at the point 2, 16. So first of all, we might graph the curve given by this equation to begin with. So it'll look something like this. Parabola going through the origin. And we're given that this point lies on the curve, so we've got somewhere around about here perhaps is 2, 16. And let's just see if that does agree with the equation. So when x is equal to 2, we've got y is equal to 16. So at x is equal to 2, we've got 2 squared is 4, times by 4 gives our y value of 16 as expected. Okay, so what we're asked to find is the equation of a tangent at this point. In other words, we're after the equation of this straight line that just touches the curve at the point 2, 16. So we're after this equation of this straight line now. The equation of a straight line will be of the form y is equal to mx plus c. So what we can do is first of all find the gradient at this point here by differentiating the equation of the curve. So if we differentiate y is equal to 4x squared, we'll get dy dx is equal to, bring the 2 out the front, 2 times 4 is 8, reduce the power by 1, we get dy dx is equal to 8x, so this is the gradient function. We can then find the gradient at x equals 2, so dy dx at x equals 2 is equal to 8 times 2, which is equal to 16. So here we have the gradient of this curve at the point x is equal to 2, and that will also be the gradient of the tangent at this point as well. So from there we can now write the equation of our tangent as, so equation of tangent is y is equal to 16x plus some c value. Remembering the c value here is the y-axis intercept for a linear equation. So if you imagine this tangent line here, as that moved on down here, it would cut the y-axis somewhere down here, so we're looking at some negative value is what we're hoping to get. Now to actually work out this c value, we can just substitute the point 2, 16, which lies on the curve of this equation, but it also lies on the tangent line. So we can sub this point 2, 16 into the equation of this straight line and solve for c. So substituting in the 16, the y value goes where the y is in the equation. We get 16 is equal to the x value. We sub that in for x here. 16 times 2 plus c. We end up here with, what do we got here? Just move up a little bit. We end up with 16 equals 32 plus c. Therefore our c value must be equal to negative 16. So we can now write out our equation of our tangent. Y is equal to 16x, take 16. And there's our solution.